This example is asking you to determine all relative extrema, that's local maxes and local mins, and the intervals where this function is increasing and decreasing. Whenever I see the language of somebody asking me to find local maxes and local mins, relative maxes and mins, or if I see somebody wanting to know intervals where a function is increasing or decreasing, those tell me instantly, either one of those. It doesn't have to be both. Either one of these alone will tell me that what I really want to be doing is a first derivative test. So first derivative test is spectacular for finding local maxes, local mins, and intervals where the graph is increasing and decreasing. The first derivative test is a three-step process every single time. It's the same 3 steps. Once you learn them, you just keep running them. Step 1 of the process is, guess what? Find the first derivative, right? So here we are given the equation f of x equals 3x to the 5th minus 20x to the 3rd. We find the first derivative. In this problem, the first derivative can be found just applying the power rule. So we just apply our basic power rule. We bring the 5 down. 5 times 3 is 15x. Subtract 1 from the power gets us x to the 4th. Then bring the 3 down. 3 times negative 20 is negative 60x. Subtract 1 from the power gets us x squared. Step 1 complete. Step 2 of the first derivative test is going to be to find critical values. Critical values occur in 2 places. They occur whenever your first derivative equals 0 or whenever your first derivative is undefined. Most people remember the first one, and a lot of people forget the second one. Don't be one of the people who forgets the second one. So in the undefined, you're generally going to be looking for if you see a fraction or a root in a problem. It's places where you would get division by 0 or where you would get roots of negative numbers. For us, we're lucky. We don't have a fraction. We don't have any roots. So really, we're just going to use that f prime setting that equal to 0. So we'll take our derivative. We'll set it equal to 0, so 15x to the 4th minus 60x squared. And then we need to solve this equation for x, so get x by itself. Anytime you've got a power of 2 or greater going on, really kind of the method is always the same for how you solve this. You would want to get this thing set equal to 0 and then factor it. Here in this one, I see that I've got a 15 that I can pull out of both of these, and I can take an x squared out of both pieces. So I'll pull a 15x squared to the front. That's going to leave me with just x squared from that first term, minus pulling a 15 out of that 60 is going to leave me with 4, and then I got rid of all the x squareds. What that then allows me to do is now I take and I break this problem up into some bite-sized math problems. So whenever 15x squared equals 0 or whenever x squared minus 4 equals 0, I'm going to have some critical values. So you just keep coming through, working your algebra, find your x values. So divide by 15, you get x squared equals 0, and then we go ahead and square root that, and we end up with x equals 0. So that is one of our critical values, our CVs is what I call it. Now we do the same thing with that other equation. So we go ahead and add a 4, we get x squared equals 4. We come through to square root both sides of this. Remember that when you put in a square root, it's plus or minus that value. So this would be x equals plus or minus 2. So we have 2 critical values out of there. We have x equals negative 2, and we get out of there x equals positive 2. Both of those are critical values. So step 2 complete. That's kind of the roughest part of this process, I would say. From the finishing out this thing, it's a number line game. So step 3 is you're going to actually do the first derivative test. So this is where the test gets its name. To do this, the process looks like this, you go ahead and draw out your number line, and you're going to mark your critical values on this. So I've got a critical value at -2, I've got a critical value at 0, and then I've got a critical value at 2. From there, I'm going to come through and I'm going to choose test values from each of those regions. So I need something to the left of -2. I'm going to choose -3. So my test value is x equals -3. Something in between -2 and 0, choose easy numbers. I'm going to choose -1. Something between 0 and 2, I'm going to again just choose 1 in that situation. And then something out here to the right, I'm going to choose 3. So how many ever intervals you have marked off by critical values, you need to choose a test value from each one of those intervals. From there, what you'll do is you are going to test all of those values. This is a first derivative test, and so we are going to test everything in the first derivative. Remember, math people are not creative namers. If it's called the first derivative test, it's called that because that's what you do. So we'll take f prime, we'll plug in -1, we'll plug in -3, we'll plug in 1, we'll plug in 3, and we'll get out whatever those values are. We are plugging all of those into our first derivative. So use your calculator, use your brain, however you need to do it to get out your answer. When we plug in -3, we are going to get out 675. When you're doing this process, you could care less what the number is. What you're really looking for is just positive or negative. So to the left of -2, this was positive and therefore increasing coming into that critical value. Plug in -1 to our derivative and we get out of there -45. So again, don't care about the number, just care that it was negative and therefore decreasing coming into that. Then I'm going to plug in 1. I get out another -45. So again, decreasing coming into that. And then from there, plugging in 3 to that derivative, we get out another positive 675. So positive and increasing. So that's all we need. At this point, you basically use your first derivative test number line to answer all the questions that they wanted to know. So the first thing they want to know from us is they wanted to know relative extrema. So relative extrema are maxes and mins. So they want to know what is the relative max, where are those located at, and then where is the relative mins. And you can have multiples of these depending upon your graph. So maxes are going to be where we go from positive to negative, increasing to decreasing. You can kind of draw the shape of the graph right there. And you can see that at -2, at x equals -2, we're going to have a relative max. Then looking for mins, that's going to be down up from negative into positive. That's when you'd be seeing a min. You can see the shape once you draw it in. So that would be happening at x equals 2. From there, depending upon, your instructor, they either want a full point or they just want the x values where relative extrema are occurring. If you need the full value, you are going to plug this back into the original function. Those are just the x values right there. The actual maxes and the mins are the y values that go with those. So you would plug in -2 and you would plug in 2 back to that original equation. So plugging in -2 to this equation, you would get out of that 64. Plugging in 2 to this same equation, you would get out -64. So you've got a relative max of 64, and it occurs at x equals -2. You've got a relative min of -64, and it occurs at x equals 2. So we've answered the first part of the question, where do we have relative maxes and relative mins? And so for the final part of this, we need to answer where is this function increasing and where is it decreasing? Increasing and decreasing, that's our positives and negatives off of our derivatives. So again, look back at your number line. So reading off our number line here from step 3, we would say that our graph is increasing starting here at negative infinity and ending at negative 2. During that section, our derivative data was positive. So it is increasing from negative infinity to negative 2 and then not at negative 2. It is also increasing down here on the other side. So that would be starting at 2 and heading off to infinity. You would put this little union symbol, which means connect these two intervals, and then 2 off to positive infinity. And again, use a parenthesis there and not a bracket, because the 2 is not included. The tricky part on this problem is the decreasing section. This graph is decreasing starting here at negative 2, and then it does not end again until over here at positive 2. So from negative 2 to 2, this graph continues to decrease. So this thing is decreasing from negative 2 to 2. A lot of people miss this because they group it together with the idea of where is the derivative negative. These are two different things happening here. And a lot of people don't pick up on this. Decreasing means every value to the left is going to be larger than every value just to the right of it. And so even in this situation at 0 here, some people will get lost and think that because it goes horizontal for a second, it stops decreasing. No, it doesn't. It just has a horizontal tangent line for that moment. So that doesn't tell us if it's decreasing or increasing. Decreasing, it would be decreasing across that entire interval because there's no gap in our negative situation. If you were being asked where is the derivative negative, then you would end up in the situation where you would say negative 2 to 0, then not at 0 because 0 is a critical value, but then beginning again at 0 and ending at 2. So when you end up with two intervals back to back that are the exact same, it does not stop doing that behavior at that critical value. Be careful. That is a little nuanced piece to this problem and to these answers that a lot of people, sometimes even your teacher, will not pick up on. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.